Welcome back, children. Now we can do exercise 13.3 based on Bayes theorem. So before doing the problem, what is Bayes theorem? Let E1, E2, etc. En be a partition of a sample space. Partition means P of Ei, that is probability of these E1, E2, etc. En are events. So P of Ei, the probability of each event should be greater than 0, and the union of all these events must be the sample space, and they should be pairwise disjoint, that is intersection of two events must be a null set. Then we can say that this set form a partition of a sample space. Then how to calculate P of Ei? P of Ei given A, that is probability of Ei given A is equal to P of Ei into P of A given Ei divided by sigma P of Ei into P of A given Ei. Here we can write I is equal to 1 to n. Okay, so this is the Bayes theorem. Using that we have to do the sums. So look at the first question. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the two bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball drawn is from the first bag. So once again you read. First you have to understand what is the experiment, what is the random experiment. Here we have two bags, bag 1 and bag 2. Okay, and in bag 1 4 red and 4 black balls, and in the second bag 2 red and 6 black balls. Then the experiment is we have to select one of the two bags. Either you can select B1 or B2. Then after that take a ball from that bag. Okay, so here we have to define events. Then so that is the experiment. We have two bags, one of the bags you have to select, then take a ball from the bag, and it is given that that ball is red color. Then the question is, what is the probability that the ball drawn from the first bag? Okay, so the color of the ball is given. We have to find what is the probability that it was taken from bag 1. So we have to define events. So we can define, here we have two bags, so we can define E1 and E2. E1 means selecting or choosing first bag. Then E2 means choosing second bag. So this E1 and E2 form a partition of the sample space. Okay. Then one more event, that is A. In that Bayes theorem result we have E's and A. So A means this, the ball drawn, that is which color? Red color. So drawing a red color ball. Red ball. Now you have to write probabilities of these events. So what is P of E1? What is the meaning of P of E1? E1 means selecting the first bag. How many bags are here? We have two bags. Then selecting first bag means 1 out of 2. So P of E2 also. E2 means selecting second bag. There are two bags, second bag selecting. That means it is 1 out of 2. Now what is P of A given E1 and A given E2? P of A given E1. What is the meaning of this? It's a conditional probability. A given E1 means this happened first, denominator. That is E1. E1 means we selected bag number 1. Then A means selecting or taking red color ball from bag 1. So, what is the probability that? So, looking this B1 and B2, A given E1 means selecting this first bag. Okay. So, in first bag how many red balls are there? 4 red balls. So, what is the probability that P of A given E1 means probability that the red ball, we are taking red ball from the bag 1. Okay. So, its probability is 4 out of total number of balls 8. Okay. It is 4 out of 8. Now, what is P of A given E2? A given E2. This happened first, then only A. That is, we selected bag number 2. Then from bag number 2, taking a red ball. So, how many red balls in bag 2? 2 red balls. So, the probability is 2 out of total number of balls 8. Now, what is the question? The question, the ball in our hand, that is red color, what is the probability that it was taken from bag number 1? So, how to denote that? So, P of, find the probability that it was from bag number 1, that should be in the numerator, that is P of E1 given, what we know? We know that the ball is red in color. So, it is in the denominator. Okay. So, P of E1 given A, that is only we have to find. If it is difficult to write E1, E2 and A given E2, you can start from the last sentence. Okay. Find the probability that ball drawn from the first bag. So, when we read the question, there are 2 bags. So, that you have to write as E1 and E2. So, E1 is selecting first bag, E2 means selecting second bag. Then in the question, the experiment is taking a red color ball. So, that you have to define as A, drawing a red ball. Okay. Then write the corresponding probabilities. Then what is the question? We have red color ball in our hand. Find the probability that it was taken from bag number 1. That should be in the numerator. Now, write the formula. What is P of E1 given A? P of E1 given A is equal to, according to Bayes theorem, it is P of E1 into P of A given E1 by sigma. Actually, it is in the denominator. Sigma means sum of what? P of E1 into P of A given E1. Here we have 2 events, E1 and E2 in the partition. So, first we write based on E1, now E2. P of E2 into P of A given E2. Okay. Now, substitute the values. P of E1 is 1 by 2. 1 by 2 into 4 by 8. Then 1 by 2 into 4 by 8 plus 1 by 2 into 2 by 8. 1 by 2 we can take outside and cancel. 1 by 2 take outside, 4 by 8 plus 2 by 8. 1 by 2 cancel. So, 4 by 8 by 6 by 8. 8 cancel, 4 by 6 or that is equal to 2 by 3. So, 2 by 3 is the required probability. Okay. Now, the question number 2. In answering a question on a multiple choice test, a student either knows the answer or guesses. Let 3 by 4 be the probability that he knows the answer and 1 by 4 be the probability that he guesses. Assuming that a student who guesses at the answer will be correct with the probability 1 by 4. What is the probability that the student knows the answer given that he answered it correctly? Okay. So, in answering a question on a multiple choice test, a student either knows the answer or guesses. So, only 2 possibilities. Okay, either knows the answer or guesses. Then probability is given. 3 by 4 be the probability that he knows the answer. And 1 by 4 be the probability that he guesses. So we can define the events E1 and E2. E1 means student knows the answer, E2 means student guesses the answer. So P of E1 and P of E2, that is given in the question. Now what is the next step? Assuming that student who guesses at the answer will be correct with probability 1 by 4. Okay, student guesses, then the answer correct. Its probability is 1 by 4. So if student knows the answer, and what is the probability that the answer is correct? That is equal to student knows all the answer. So the correct answers, the number of correct answers will be, or the probability of correct answers, that's equal to 1, isn't it? Then what is the probability that the student knows the answer given that he answered it correctly? So the question is student answered correctly. Then what is the probability that he knows the answer? Okay. So we define the events first. So here we have two cases. As in the previous question, we have two bags. Here the student either knows the answer or guesses. So we can define the events E1 and E2. E1 means the event student knows the answer. Knows the answer. And E2 means student he guesses the answer. So what is P of E1? P of E1 is given in the question. 3 by 4 be the probability that he knows the answer. And P of E2. And 1 by 4 be the probability that he guesses. Now what is A? What is A? Here, look, what is the probability that the student knows the answer given that he answered it correctly? That is given that. Actually, in these all questions we have to find EI given A. So this A, EI means E1 and E2, student knows or student guesses. This A part is this one. Given that denominator part is he answered it correctly. Okay. So A be the event, student answered correctly. Now what is the probability that P of A given E1? P of A given E1 and P of A given E2. What is the meaning A given E1? E1 means student knows the answer. A means the answer is correct. Suppose there are 10 questions, 10 MCQ questions, and students knows everything, all the answers he knows. So the number of correct answers is 10. That is 10 out of 10. We can write like that, 10 out of 10. So its probability is 1. Understood this? A given E1 means the student knows the answer, and what is the probability that the student answered correctly? So everything he knows. So he answered all, he write all the, for all the question he write the correct answer, isn't it? So the probability we can take as 1. If there are 50 questions, he knows everything, that is he scored 50 out of 50. So it's equal to 1. Okay. Now what is this one? A given E2. E2 means student guesses. He don't know the answer, he just guesses and write the answer. And A means that answer is correct. That is given in the question. Okay. Look here, assuming that a student who guesses at the answer will be correct with probability 1 by 4. So this one is 1 by 4. Now, what is in the question? The answer is correct. That is in the denominator, and find the probability that student knows the answer. That is in the numerator. Knows the answer means E1. So P of E1 given A, that's only we have to find. Now write the formula. What is P of E1 given A? P of E1 given A is equal to P of E1 into P of A given E1 by P of E1 into P of A given E1 plus P of E2 into P of A given E2. Now P of E1 means 3 by 4 into A given E1, that is 1. Then again 3 by 4 into 1 plus 1 by 4 into A given E2, that is also 1 by 4. Okay. Now simplify. So it is 3 by 4 by 3 by 4 plus 1 by 16. Taking LCM in the denominator, 16 is the LCM. So we have to multiply by 4 here. 4 into 3, 12. So 12 plus 1, 13. 16 by 13. It's equal to 12 by 13. So that is the required probability. Now the third question. There are 3 coins. One is a two-headed coin. Two-headed coin means both sides head, no tail, both sides head. Another is a biased coin. Biased coin means, unbiased means equal chances for getting head and tail. That is 1 by 2, 1 by 2. One side is head, one side is tail. So equal chances for occurring head and tail. So probability of each is 1 by 2. Biased means it is not like that, not equal chances. Maybe getting head is more than tail or getting tail is more than head, like that. So that if it is a biased coin, that will be given in the question, what is the chance of getting head or tail. So the first coin is a two-headed coin, second one is a biased coin, and it is given that comes up heads 75% of the time. So heads occurring 75%. That is 3 by 4 is the probability of getting head and 1 by 4 for getting tail. And the third is an unbiased coin. Third one is unbiased coin. So there are 3 coins. One of the 3 coins is chosen at random. So now what is the experiment? We have 3 coins. We have to select one of the coin. Then toss the coin. It shows heads. What is the probability that it was the two-headed coin? Understood the experiment? There are 3 coins. We have to select one of the coin and toss it. Then check how many heads appeared. Then what is the probability that it was the two-headed coin? And here it is given, it shows heads. So head appeared. Then what is the probability that it was the two-headed coin? Okay. So how we defined events here? Look here, one of the 3 coins is chosen. So there are 3 coins. So we can define E1, E2 and E3. What is E1? Two-headed coin. We have to select two-headed coin. Selecting two-headed coin. And E2 means selecting biased coin. And the third one, selecting an unbiased coin. Okay. So what is the probability? P of E1. We have 3 coins, selecting one of the coin. That is the experiment. So selecting two-headed coin. Two-headed coin only 1 out of 3. So that is same as P of E2. P of E2 means selecting biased coin. That's only 1 biased coin out of 3. Then P of E2, selecting unbiased coin. That is only 1 out of 3. So all the Probability is P of E1, P of E2, P of E3, 1 by 3. Now define the event A. What is A? After selecting the coin, you have to select one of the coin, then toss it, then it shows heads. Then what is the probability that it was two-headed coin? That's the question. So A means getting a head. Okay. Head appeared or getting a head, that is the event A. Now we have to write A given E1, A given E2, A given E3. What is A given E1? E1 means it is a two-headed coin. So you selected two-headed coin, then toss it. Then what is the probability that getting a head? Both side head. So probability of getting head means 2 out of 2, that's equal to 1. Since it is a two-headed coin. Now P of A given E2. A given E2 means E2 is the biased coin. Selected biased coin, then toss it. So what is the probability of getting a head? For biased coin it is given in the question 75% is the chance for getting head. So 75 by 100. Or we can write it is 3 by 4. Now what is P of A given E3? E3 means unbiased coin. Unbiased coin, selecting unbiased coin, then toss it, then what is the probability of getting a head? One side head, one side tail. So getting a head means 1 out of 2. Now what we have to find? We have to find E1 given A, isn't it? A means the coin shows heads, that we know. We have to find what is the probability that the coin was two-headed coin. Okay, so E1 given A. Now write the formula P of E1 into P of A given E1 by denominator there are 3 terms. Sum of 3 terms, P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into A given E3. Substitute the values. P of E1 is 1 by 3 into 1 by 1 by 3 into 1 plus 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 3. So 1 by 3 we can take outside. 1 by 3 into 1 is 1 by 3. 1 by 3 taking out. Then 1 plus 3 by 4 plus 1 by 2. 1 by 3, 1 by 3 cancel. So it is 1 by LCM is 4. 4 plus 3 plus 2 or 4 out of 9. Okay, check it. Taking LCM, then taking the reciprocal, it is 4 out of 9. Now the next one. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false positive result for 0.5% of the healthy person tested. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? Okay. Once again you read. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. Okay. Now, but the test also yields a false positive result for 0.5% of the healthy person tested. That is, when a healthy person tested, there is a chance for positive result. That is how much the probability is 0.5 percentage. That is 0.5 by 100 or 5 by 1000. That much is the probability that a healthy person when tested gives positive result. When a person who has the disease, the blood test is positive, this is the probability 99 by 100. Then 0.1 percentage of the population actually has disease. So this one gives how much, what is the probability that how much percentage has disease. So we can find its complement also. What is the probability that a person has the disease given that his test result is positive? So if it is difficult to identify the events, you can just check the last part of the question. What is the probability that a person has the disease given that his test result is positive? Okay. So that means P of what we have to find. Usually the notation is E here and A here. Okay, in the denominator, E in the numerator. So here what is A? Given that is in the denominator, conditional probability. So given that his test result is positive. So we can define A as test is positive. Now what about E? E means not only one, even there are E1, E2 like that. So what is E1 and E2? A person has disease. So what is the next possibility? A person has disease. The other case we can take person has not disease. Okay. So we can define E1, E2 and A. So what is E1? Selected person has disease. We have to select a person and the person has disease. That is E1. So E2 means the person has not disease. He is a healthy person. Now what is the probability? It is given 0.1% of the population actually has disease. So we can write P of E1. P of E1 means the person has disease. So what is the probability? 0.1%, or we can write 0.1 by 100 or 1 by 1000. Is it correct? Multiplying by 10, numerator and denominator. So it is 1 by 1000. Now what is P of E2? P of E2 is the complement of E1. So we can write 1 minus this much of the population has disease. So the percentage of population has not disease means you have to find the complement. So complement of this number 1 minus 1 by 1000. That means 999 by 1000. Now what is A? Test result is positive, blood test. We have to select a person and we have to check whether the blood test is positive or negative. Test result is positive. Now what is P of A given E1? A given E1 means selecting a person who has disease. Then his blood test, we have to check his blood test. How? If a person has disease, then blood test is positive in 99%. Okay. So we can write P of A given E1 as 99 by 100. The test is 99% effective if a person has actually disease. And A given E2 means the person is a healthy person, but sometimes the test result is positive. That is given in the question. The test also yields a false positive result for 0.5% of the healthy person tested. So 0.5 percentage, 0.5 percentage, or how can we write, by 100, or it is 5 by 1000. Now the question is, the test is positive and the person, what kind of person? Person has disease, that is E1. So this is equal to, by Bayes theorem it is P of E1 into P of A given E1 by P of E1 into P of A given E1 plus P of E2 into P of A given E2. Now substitute P of E1. What is P of E1? 1 by 1000 into A given E1, that is 99 by 100. Again 1 by 1000 into 99 by 100. Then plus E2 is 999 by 1000 into A given E2, that is 5 by. Okay. So 99 by, how many zeros? Okay, 1 lakh by, taking LCM. So 5 zeros, here 6 zeros. So 10 lakh. Okay, 6 zeros. So here you have to multiply by 10. So 990 plus, then multiply. Okay. So this cancel. So 99 by, here 1 0 left. Okay. So 99 into 10 by 4995 by 990. 5985. You can cancel by 5. So 1 5 is 5, 49. 49, 9 5s are 45, then 440 is 198 by 1, 1, 48, 45, then 7, correct? 9, 10, 8. Then divide by 9, 2 9s are 18, so it is 22 by 1 9 is 9, then 29, 3, then 27, 3. So 22 by 133. That is the required probability. Okay.